Hello, pokalbį apie kokybę listeners. So you're probably watching this on YouTube or listening to that on Spotify. And someone's actually tested them. And today we are talking about audio video testing, and we have two experts who have quite a lot of experience in actually doing the testing for audio and video, like software and services. So maybe let's start with Deniss, and could you introduce yourself to our audience?
Sure, yeah. Hello, dear audience. My name is Deniss. I'm technical director here at TestDev Lab. Been here since 2012, so I'm one of the first two employees in the company. Had the privilege to see the company grow from a couple of employees up to now we're almost 600. So that's quite an achievement, and thanks to our both co-owners who are ex-Skypers. So we come from communications field.
Audio video testing, right, as well.
Yes.
It's a circle.
And interestingly, we did not start with audio and video testing. We did start with plain old functional testing, but without it, nothing actually works. So it is. And what I do here at TestDev Lab, I oversee different projects, including audio and video projects. I'm not acting as a project manager. I was at some point for some critical projects, but we have grown to have different project managers, technical project managers who are very fond of this specific, we can say, niche of an area for testing. And main goal would be to enhance our capabilities and improve the services and the products. A lot of different internal projects focused in doing that alone. And I'm trying to push, not push mentally anyone to some kind of a brink, but push people to think outside of the kind of box. That's kind of a cliche, but I think it's important to encourage people thinking outside of their daily responsibilities and kind of daily agendas. So to have that competitive edge in AV and not just that area of testing.
Okay, nice. Thank you. And now we have our another guest, Alvaro. Introduce yourself to our audience.
Yeah, sure. So I'm Alvaro. I'm head of research and development at TestDev Lab, and I've been working here for over 4 years now. I didn't start with like the first one or two people, so I'm not as I don't have that longevity as Deniss, but we were about 80 or 90, and once I got there, we just turned 100 almost that same year. So, and after that, the company just started growing exponentially. Like 4 years from now is like next year we were 200, the next year like 400 almost, and so on. Like it's been quite a journey through these years. And at the beginning, which is interesting because I only have 4 years in this industry, I started as a trainee. But since I have this like inner drive to develop and get new knowledge and build new frameworks and tools, so I started building those for the company, creating new frameworks for automation, and then helping out with internal development initiatives like Appimation, LiDAR, and like I work in many different projects for like these 4 years. And just in the last 2, we started with audio video testing, and I took responsibility for the automation part. There was nothing related to automation, and we built it from scratch, pretty much.
And it was that small client, right?
That small client, yeah. Well, we started developing these automation frameworks. I talked about in the previous meeting that we had, like a test ray. And then we started also developing new metrics. Then we actually got the proper research and development department. So to formalize all the things that we've been doing through these years, but now with an actual team to take over the task that we have, because even though most of them are related with audio video, there are other things related to just testing that like improve the procedures and capabilities of test-of-lab testing infrastructure.
All right. So you mentioned that you started, then there was nothing for automation. Like there was nothing in the company or nothing in the world.
There was
For AV.
for audio video.
For audio video, yeah.
It's a good point. So like, up until there, we were just like throwing the stones and
Walking into the stick.
Had square wheels. It's fine. It's fine. We don't need any help.
Exactly. So there was a tryout of like some sort of automation framework, but they didn't like pull all the pieces together. And this is quite important because on audio video testing you have to do like UI automation gestures and clicking, and not only for desktop but also for mobile phones, which are Android and iOS. And since we do like full end-to-end testing, which includes real devices, well, things get a little bit more complex, because when you use simulators or emulators, you get rid of the hardware part and you don't have to maintain it. But we need to use like real devices to simulate actual real users. Otherwise, for audio and video testing, you are trying to simulate all the GPU, CPU of those devices, and the performance is not the same. So you won't get real reliable data for the clients. And this makes things a little bit more complex, and that's why like we developed a framework that was able to control all of them. But at the same time, we need to run the frameworks for recording, the frameworks for analysis, and there wasn't also a platform to do data analysis. And so I actually developed all the things just on a basic level, of course. Like I didn't make it pretty. I'm more like a backend developer. Like, let's say I know some front-end developer, but like my design skills are like HTML and simple CSS.
Deja vu.
Yeah, it's kind of like white background and maybe some things, not animation at all. Like it's quite basic, and any designer will look at it and think like, oh my god.
All the page has just like text and blue colored links.
Yeah, code just going
and then it turns violet or purple.
Yeah, kind of like
when you load any page and you don't have the CSS files loaded, that's how.
Yeah, very much.
Because there were no CSS files, right?
Yeah, well, there kind of was. So
inline styling, right? Like everything like a generic element style
included in
display.
HTML elements. Yeah.
Yeah, I mean it wasn't so bad. I learned React JS and I had some templates from Bootstrap, but still it wasn't like after I handed that to another team. I actually like that led to a new team surrounded by just the platform for data analysis, which is like the Tempero team. And they are basically just delivering the front-end user experience for the client, so that they can explore all the data related to the video, audio quality metrics. And so it was intense at the beginning, because it was kind of like blank space, and then you need to pull all those pieces together, and it's a bit overwhelming because the client wants things. They want to see stuff happening. It's like we want testing, we want this, and we want this, and when do you want it? Well, we want it from yesterday. And
Classics.
It's classic client request. And I just tried to pull that off as soon as I could, even if it was just the bare bones, but at least we could show that we can have that kind of capability within TestDevLab. And most of those proof of concept, they started to take attention. And then, well, by just moving the word around, they said, okay, so you do this and you're able to actually do end-to-end testing, because there are almost no other company that does like real end-to-end testing on audio video applications. And so that's very interesting, and mostly because end-to-end testing is not just the algorithms behind the compressions, the codecs that they use, but it's also the rendering of the device, how it behaves on the specific device, and also do some sort of investigations about what is your population, like the usage, what devices your client, your customers, or the clients that use the applications use. And so we focused on that, and it's very interesting to see like difference that they get from telemetry from the actual real life expectations, and sometimes they get some surprises. So and yeah, that's only like some part of it, because when I talk about recordings and analysis, we also do network simulation, and that's like the key of this testing, because from network simulation we get so much information. And yeah, I'm taking a lot of time for this question. So
Oh, that's really good.
I can maybe quickly add here. So to have like an analog comparison would be to see what is in functional automation. So as long as you're inside a browser automation, that's fairly well controlled environment. And when you get out of it, when you look at different mobile devices or any handheld device, and well, embedded systems, that's a whole different level. But even on the desktop systems, it gets complicated pretty quick with all the interoperability variables that are there, and that I would say compatibility of different devices with these applications is something of the complex case, and also of a great interest for those developers of those applications, because it's not something they usually do and have the resource to do it. So obviously they stick to kind of software level of testing, obviously kind of unit and maybe integration parts. But I think that's the benefit of having a partner which who can help with these extra resources and of having those laboratories. But we've also seen when clients themselves have laboratories, and that's a bit more in-depth topic. We can expand later, but I think just think of your regular functional automation, and that's very similar to what we experience.
So if I have a task to test audio video application, where should I start, and what do I need to know in order to do that testing?
Okay. So you have an audio video application and you want to start testing it.
Yeah.
Well, at first we will need to understand like how.
But are you acting as a client or as a tester?
So we can do YouTube, right? So people probably looking at YouTube right now. So we can start with the YouTube. And how would you test YouTube?
Okay. For testing, there is one thing that is quite important, and is that you can do repeated tests, and that you can track the situation over time, and also that you can do look back and catch regressions and things like that. This is important in terms that if you are constantly changing the test conditions and you're testing like different videos and never repeating, then you might find bugs that were there previously but you didn't catch them, or you might find that things are behaving better but they are actually not behaving better, it's just different content. And so the application just behaves like a little bit better on that specific content. And this means that don't mean that you shouldn't test on different types of media content, because it is also important to explore the variety of things that a user can upload to the internet. It's not like we can only test like spheric chickens in space. So a physics joke. So you still need to do some exploratory testing, and most of that happens through manual testing, because making that automated is sometimes not within the scope of the application, and mostly for those applications that works in a 2-week release. So like making automation scripts for pretty much everything doesn't make sense. It's not doable. And
that would actually be a recommendation. Like first step to start with would be exploratory testing.
Yeah, that's kind of the first thing that will happen, which is manual exploratory testing. And this brings to the topic of like, can we automate everything and get rid of manual testers? Well, I don't think we are there yet, not even close.
I share the same.
So, and this is very important, because this gives us like quick insights about how the application behaves, and we can still use the algorithms that we have at TestDevLab for video quality, for audio quality, and so on. So for YouTube, for example, we could upload a specific media or a specific like a range of media files that could be like active content, presentations, podcast, 4K videos, 8K even, because I think now you can do that, and or low quality videos, and then with different sorts of audios. Of course, we have to keep it at like at a certain extent, because you still need to deliver some sort of data to the client in a timely manner. And once you've defined all of those, we do that kind of exploring. Well, is the quality as it should? And we will also do the network simulation, because this is something very important for most of the streaming and video call conference applications.
So just to reiterate, so you have some kind of a list of video files and audio, like you just, I don't know, let's say 15 different videos with 15 different audios, right? You upload them, they are different quality and whatever. So this network simulation is not for upload, right? So those videos are on YouTube, and now you're going to try to watch them. What is that? Streaming?
Playback.
Yeah,
playback, right? So on that playback, that's where you introduce the
network simulation. Yeah, we do that like with a man in the middle, which is a router that will do this network simulation as it happens on network providers. And the only thing is network providers that don't do like network simulation, they do network limitations, so that like you don't get over congested areas of network. And well, I mean, for Ethernet it's a different thing, they just limit it because you have higher a specific bandwidth. But there could be in network simulation is a whole world, because you can have problems of connectivity, not just because your provider is not giving you the right signal, but because the route to the servers that are hosting that like YouTube videos are like, that route is corrupted at some point, or there are packet losses or some like different network connectivity issues. And it is not you are not going to just use the network provider and hope that you will get some error in connection. Like, you will want to simulate it, and by doing that you will see how the application behaves, and there are very interesting behaviors depending on the network simulation. And then the streaming service or video call conference should deal with it in a proper way. So if there is bandwidth limitation, they should send less amount of data, or at least send the data in a compressed way. That's why like YouTube have different resolution, and then they have like a automatic resolution, that they send automatic resolution. You can fix it, but then you will have a lot of like lags, and it will stop time to time. But if you set it like in regular setting with the automatic resolution, they will degrade the video. Actually, these videos in YouTube, they are uploaded in different resolutions. because they do it that way, and they just send the version that is fitted for the user. And then you will see, what happens if we put like very low bandwidth. We see like a decrease in resolution. Okay, it works as it should. Is it using all the bandwidth that is available by the network? It's not. Then there is a problem, because they are just having this gap, and it shouldn't happen. For packet loss situation, is like, are they resending the packets, or are they skipping? Is like all the frames are there? Are we having like this 30, 60 frames per second, depending on the monitor and so on? And so there are a lot of things to simulate, but we in that manual testing part, we often do like the recordings of this test, and we do the post-processing analysis, and then we get all the data. But then we have to digest it in a way that we can present it to the client, because that's one of the important things that we do at Tesla Lab, which is giving meaningful reports to the client and try to give some insights about what could be the problems, or how they compare against competition.
So again, then to iterate, so you uploaded the video, then you downloaded it with different setups of network, and then you have to record the video, right?
Yeah, well, you play back in the platform. So it's like YouTube, you play back and we record that.
Record the screen.
Record the screen. And then you have to process that video to get meaningful insights, right?
Well, yeah, you get the screen recorded, and from that recording, you get, you decode that video into sequence of frames, and each frame is an image. So what you can apply, we can already kind of start talking about different metrics. So what it is specifically to test it. But I'd just like to jump back a little bit for the audience to understand that this network simulation or network limitation, applying those network limitations is nothing that complex, I would say. Well, it has complexity, obviously, if you don't know about it. But I'd like to just say that if you have a computer, simple like laptop, and let's say on a Linux, you can do IP forwarding. So you enable IP forwarding, you change IP tables to route traffic from your router. So if you have an ISP router, you can connect it to the Linux or whatever OS computer, laptop. You then route all the traffic that's coming in from the ISP side into that specific network interface, and then you route it to, for example, if you have a USB adapter with an Ethernet cable, you can hook up your testing device if you're doing a wired connection. And then on that Linux, you can use traffic control. That's a tool set on Linux where you can limit bandwidth, you can enable packet loss, and other network conditions that can have limitations.
It's a good, it's a good opportunity to ask. I remember that you said that there are 7 parameters for network connectivity. Is that correct? And can you name them? Just don't go to the details, just name them.
About 7. I hope they are 7. Let me recall. So there, this bandwidth, it's packet loss. There is round trip time. There is jitter. Jitter is sometimes.
No, go through it,
Okay,
and then
jitter.
we'll explain.
Okay. Then, God damn it. Bandwidth, packet loss, jitter. Are they 7? Maybe it's just like upload and download. And
No, so the bandwidth, then you can have packet count.
Ping.
Well,
Latency.
ping is
No,
RTT.
Ping and RTT, yeah, those are like.
So round trip time is the time it takes to get from one end to the other. It's like end-to-end latency. So it can be, but you can also measure. So ping is just ICMP protocol kind of traffic latency, but you can have different protocol latencies.
Also, you have different types of ping.
Kind of. Well, ping is also only ICMP. If you want to do other types of latency checks, you just call them just round trip time, so RTT. You can do RTT on simple UDP, but if you want to have a very specific protocol, if you go one level down, then it's RTT. It's RTP RTT. So RTP streams, which you have on both video and audio, and then you can have that. Because if you measure ping, it might not be the same as the RTT for the actual stream, and in most cases it's not, because ping just reaches some part of the software on the server, and it can be just another instance, and it will certainly not reflect the real situation which AV servers would be in. So yeah, I don't know. You can get 7 and actually more. It just depends on what are you trying to measure. But mostly it would be, again, bandwidth, packet loss, jitter, RTT. So those four are the critical ones. Then you can look at the other stuff.
But it is true that you can do bandwidth in the upload and download, and you can do packet loss in the upload and download. Like, they can be different. So that could be why there are 7. So we have 4 there. Then we have like a RTT, which is also like upload and download, and then we have jitter, which is like just jitter.
So 3 of them are multiplied for upload and download, and one is common for all.
Yeah, it's just like for jitter, it doesn't really make much sense to maybe divide it, because it's kind of like jitter.
Can you maybe explain what is that jitter? How do jitter? So if
it's Spanish way of pronouncing things.
Sorry, but if I'm watching like a video on my phone, like and I see some defect, so what would I see if there is jitter?
Well, that's a interesting question, because
I expected it's simple question.
Yeah, it is, because it's not the jitter. Sorry, it's a time. It's related to the packets, how much time it takes to reach you, and jitter happens when there are different latencies between packets, which means, imagine you have packet 1 that has gone out from your phone, and packet 2, which has gone later from your phone. But then it goes to the server, it comes back to the other device, and the second one arrives sooner than the first one.
It can happen.
Mm-hmm. It can happen. So in that case, that's why like packets are numbered, and this is because on UDP, on video call conference applications, you don't get confirmation of arrival. And when you send a packet, you just hope it has reached the destination, but you don't wait for the confirmation.
Well, for all streaming apps.
No. For streaming services, they use TCP. So
not all.
Well, not all, but most of them. Well, some of them they use. Well,
let's get back.
The thing is, so you throw the packets, and they arrive in whatever order they want, and that's like, if there wouldn't be any jitter, they will arrive in an order way, but
in the same sequence.
But this is not always the case, and sometimes if you have high jitter, that will mean that you will have very disordered packets, and the application have to order them and kind of predict if imagine like you have received the 3rd packet, but you haven't received the first packet, and you're like, okay, now I have received the 4th, but I haven't received the 1st. Am I going to wait until I receive the first one, or I'm going to still waiting until I don't know, like for how long I'm going to wait for the first one, or maybe it's lost.
So that's kind of this jitter buffer that needs to be thought of when you're building the app.
And there are some situations, this is why like it affects in different ways. There are some applications that they see jitter as maybe packet loss, or they feel it's like maybe bandwidth limitation, so they are not receiving at all, and they will degrade the image heavily, like a lot. And it's like you have plenty of bandwidth, you have plenty of you don't have packet loss whatsoever, but you have like maybe 100 milliseconds of deviation for jitter, because jitter is like deviation on time. It's not like physical, like one is deviation, and suddenly the quality just goes down. Like it's impressive how bad it can go. And some applications, like you can see it while simulating, because those situations are not so common. In some places they are, but when you see them and you think like, okay, but my network connectivity is good. Like you're in a train, and you see like if you do like speed test or some like test for your speed, you see like, well, I have like 3 megabytes of bandwidth. It's okay. Like calls use less bandwidth in general terms than
2.5, something like that. Some apps maybe use
About
too
2
much.
megabits, it's enough for a video
Yes.
call, right?
Yeah.
Actually,
Or
some of them use
yeah.
much less.
So
And
2 Mbps is actually quite good for a group call. It's enough. If you have a very quality network, if you don't have jitter, the RTT is
So
low.
that's the thing. So those speed app, it shows what download, upload, and the ping. I think that's it.
Yes.
yeah,
Yeah.
they will.
And the ping is mostly, again, it's very high level metric on the speed test. It will not give you the idea how good of a RTT is for RTP streams.
Yeah, because I mean the speed test are going to test that round trip time with their own closest server. That doesn't mean it's the server that is going to be used in the application that you're using, and that could make things a little bit different. But yes, about the jitter in this case, like you could be in that, you could see those features, and yet you have like bad video quality, and you're like kind of like, why is this happening to me?
From what I understood from that jitter buffer, right? So that means that each application has its own implementation, how it handles that stuff, right? So that means that one application can be maybe decreasing the quality, other application might be skipping the frames which it didn't receive or something like that.
So that depends on, because most of these video applications, they run under the same technologies. Most of them, they use like this WebRTC like framework, and but you can play around that, and you can use different codecs, and you can like do different kind of implementations, and you can just choose to not update your dependencies ever, and so things just get a little bit clumsy, but.
Desktop apps though they can use WebRTC, but most don't use, so they use some kind of either modified WebRTC, or obviously they will take something that was already there and try to improve on it and enhance.
Yep. Yeah, but in that case they modify like the parameters, like tweak around, and those things like even the smallest thing can cause like a big difference, and then the integrations with the devices also like make a big impact, and the performance of the device itself, because sometimes the device is not able to render things and still is kind of like receiving so much information, and it just can't handle, and then how all these things, all those pieces come together sometimes is a little bit unexpected, and we get interesting insights for the clients.
Yeah, to give you a quick idea of the complexity in that level, so that level meaning developers building their own technology of transcoding audio and video. If you look at the audio and video platform market, like there are services by big companies like Twilio, for example. It's very popular, and we actually do provide testing services for Twilio as well. And they have their own SDKs, and those SDKs are practically ready solutions that you can use in your other applications and use their infrastructure for audio and video testing. But also with those SDKs, same applications using those SDKs act so much differently and behave so much differently.
So you use the same core, but it
Yeah.
produces different results.
Yeah, because you have
It's like Android, right? You have a base Android, but everyone
Yeah,
who's
different
using Android
flavors.
can like, it adds something.
Yeah, and you have maybe like 10 to 20 configuration items, and those alone already can cause you different expected results. So that's and imagine how much complex it can go on the lower level. And that's why it's so necessary to do this type of testing, and quality of experience is what those application developers are really interested in.
And I can imagine like YouTube and streaming services are quite much easier to handle because they have a buffer. They can pre-download something, and you can have a nice experience compared to real-time communication, which is then you need to make sacrifices, you need to make snap decisions. Do I need to reduce the quality? Do I need to drop something? Do I wait or not wait for it? Because it will introduce lag and latency. So it's a much more complex
And
task.
it's also the second layer, because the phone needs to take a video and send it at the same time while it's receiving and showing the video. So it's double or 14 times more possibilities for the issues on the network than on the video codec. Audio, we didn't touch that, but
Yeah, there are so many variables taking place to actually make the experience good or horrible, that is sometimes a bit overwhelming. Well, we started the automation part because the audio video testing has happened in Tesla Lab for quite some time already, more than the 2 years that I've been working on it, but I think 4 or 5. And when I started on this, the applications, most of them, they were behaving very, very weirdly, very bad actually. But we jumped into this area in a very good time. Good time.
CV.
because
Because
everyone started
COVID.
using it suddenly in the world.
Because so like it was very interesting because I got in. It was February of 2020.
Just
Still,
on time.
I remember that I was by then I was living in Latvia, and I was actually living in Ventspils, which is a different city of Latvia. We were looking at the news and we were like, oh, this won't be anything stuff. And then at the same time, like one of the CEOs, he told me, well, we have this interesting project and it's about audio video and they want automation. And I was like, yes, I'm in. and then COVID actually became a real thing. I was 1 week in Spain. I came back and I was in Spain. I was like, well, this is a ride. And then cases in Italy started to pop up, and then Spain as well, because it actually, like, when we started to freak out, it was because Italy started to have a lot of cases, and then Spain as well. And well, I didn't have COVID, so I didn't bring it to Latvia. It wasn't me. I swear. Sure.
Well, what is the patient zero? Now we know.
In Latvia. Yeah. God damn it. Good. They got
Definitely stays. They definitely stays.
As an evidence in the court.
So and then we with the news they started on, well, maybe we have to work remotely, and once like these become like a big thing, we were still working on this audio video testing, but we started having more and more load of work because they were more and more interested. It was like, well, before it wasn't so much a requirement to have automation. Suddenly, like, just get everything done. Like, we need this as soon as possible because the competition was getting harder and harder. And a lot of new applications merged from those days, and more like new like SDKs were starting to deploy, and people were using them, and and then like even some of the like big applications had like downtimes because the load was so big, so sudden that they couldn't handle it. And I remember those times. Okay, like it was down, and it was like, oh my god, is this real? Like one of the biggest applications was down, and then well they tried to fix it. Then other applications started to catch up, but it's still like you were comparing that against other, and it's like this is so much better. Why I'm going to use this? And then the other got better in some specific network condition. Like some application was good at packet loss conditions, but bandwidth it was very bad, and the other way around. And it was kind of like each of them trying to push each other, but such a fast pace. Like I saw from some of the clients the progress so vividly. They were really pushing forward, and we were we are proud to be there because we were helping to catch these bugs or these regressions and try to give them insights about how to improve, and telling them, because we do this kind of benchmarking against the competition, and so we were pointing them, well, look at this company, they are doing fine, you are not. Or that hurts. Yeah, I know, but it's part of the job. And or the other way around, like this company is actually behaving like really bad in this network condition, and you are actually doing good. So nice job, guys. keep it on. But we have trends over time, so that they can see the progress and.
So if you're doing benchmarks, so which one's the best right now?
Which network which provider or
not network provider, but I guess,
not network, but the video
tool.
call. Like what programs for video calls do you use at home?
So honestly, I can say
if you can say that, of course.
Yeah.
I'll think about it.
I'll say the one that is used most in the browser is doing really good. So the one that you have the calendars and all other stuff. Yeah. So that one is doing really great. I would say kind of the hardest part of any applications to deal with is variable network limitations. Variable meaning you have, like, for 1 minute you have unlimited network condition, for the next one you have 2 Mbps, for the next one you have 500, for the next one you have 200, and then you climb back up. So it's like what to compare to what you have in fitness, this
HIIT, high intensity,
high intensity training. Exactly that. And most of the apps really struggle with it, and it's the perfect case for a pilot. If we start new engagement with someone, it's that we do variable bandwidth and variable packet loss. So for packet loss it's similar. No packet loss, then a little bit of packet, like 5%, 10%, 20%, and honestly most of the apps go to shit. The biggest struggle for the app is not coming down but coming back up, and recognizing that there's enough bandwidth available.
Oh, so it's is it the case when I have, like, company meetings and whatnot, and sometimes some person just goes dark, like apparently his end of the app didn't handle. Yes. And he cannot cancel it, it's frozen, he tries to reconnect, his ghost is still there, he cannot do it, and he's like, it takes up to 2 minutes to get back, but sound is in. The sound is going through, just not the video.
Yeah, because sound is really taking like a smallest share of the stream, or it's not the one stream. It's the
bandwidth.
Yeah.
It's kind of like maybe even less than 10% of the bandwidth is
less than 10%.
Much less.
Yeah. But some apps also fail on the audio part, even with the available band. So for audio, you need maybe 50 kbps.
50 kilobits per second, even less.
Yeah, even less.
Compared to 2 megabits for video, right?
Yeah. Well, it's all together. So 2 Mbps it should be enough for like both streams, or more.
And actually, the thing is, actually, there are applications that they limit the bandwidth to 500 kilobits, and they don't use more because they don't need more, and they just use like compression rates for the video, so it's good enough. Some of them, it was before because they were using lower frames per second, and so they didn't really need to use that much bandwidth, and that's why like they were using less. And actually, I like those applications because you could use mobile data, and it wouldn't like. I mean, this was years back because you didn't have unlimited data. At least in Spain, we still have like some plans without unlimited data, and so having an application that uses less amount of data is kind of nice, so you don't run out of. But then there are other applications that use up to 3 megabytes, even more if they see that there are some packet loss situations. Because in packet loss situations, what they do is they send twice. They send twice.
Double
and
the effort.
Yeah, it's like just shooting like everything that you will reach. Eventually, if you shoot to all directions, some bullet will reach you. And this is kind of like one of the things that they do with packet loss situations. And since they send so much data, you receive from the receiver sometimes a lot more data. And
so you named so many different ways how application can handle or act in different situations, and those situations vary. So is it safe to say that by now you have seen it all, or does it still happen some things that
No, definitely not. I would say that we've done only the tip of the iceberg, because I believe what covers the most, so what's beneath the surface, is the ability to simulate and emulate real life conditions, what happen. Because we still do it in a fairly controlled environment. Well, we do a lot of different combinations of those limitations we talked about, but the art, I should say, is creating patterns. And this is what we simply see in this variable network limitation test. When you suddenly change the environment, the app really doesn't know what to do at that certain point. It can take, for the best apps, it can even take up to like 1 to 2 seconds to understand what's really happening. And you see a freeze, an audio cut, words start be swapped around, and
robot voice, right?
Robot
sometimes.
voice, yeah, anything. Like, app acts so crazy, and that's just a very bit of the taste what could happen in those different situations you don't know about.
There were, as I said, like in the beginning, we saw like a lot of different weird behaviors, and then they started fix. But some of them were also related to, like we said, like audio takes a little bit of bandwidth and video takes the most. And we saw like some applications that at the beginning, they were using all the available bandwidth for the video when we were limiting. And then they didn't have any room for audio, and then the audio was terrible. So because even if it was just a little bit, they weren't allowing that little bit to pass through, because
video had priority over audio.
Yeah. And that's crazy, because I mean, audio, you just take like such a little bit, just give it just a little bit of room, just a bit.
And that's the priority. That's fine if you don't see me, at least hear me.
Yes. The conversation is still happening.
Yeah, and that's actually another thing that we try to do at Tesla Lab, which is recommend to the client what to prioritize sometimes, because in video quality, what is important? To have a beautiful picture quality, or have fluidity, or what is like for the user experience. The user will much rather have maybe something between like 8 to 10 frames per second, and some more or less you can see shapes, rather than not seeing any shape but having 30 frames per second. because it's like, okay, I'm just seeing like a blur thing. Like, why I'm even seeing this? It's just like, yes, it's 30 frames per second. Good job. But it's just like one color is like being blind, like 8.
A really
2
good
pixels.
image.
Yeah.
So reasonable amount of pixels and 8 frames, right? That's a sweet spot for bad.
Yeah,
Sweet spot 15.
Sweet spot is 15, yes, but you can live even with 8 to 10.
You can live.
You can live with it. But there is one thing about frames per second, and is that there is a distinction between frames per second and fluidity, which means like, imagine you have 5 frames, but you have only those 5 frames in the 98 millisecond. Yeah, in just like 2 milliseconds, those 8 frames pass, like just speed up.
Oh.
But then the rest of the time you have freeze, complete freeze, and so you have kind of like a very clumsy, like stumbling. Yeah, exactly, and that's super annoying for the audience and for whatever client is using it. So sometimes the client will see, oh well, I'm having like a normal
Great
frame rate, like even like 30 frames per second, and it's like.
But it's stuttering, right?
So now in video calls, you have an ability to remove background or blur it. Did it introduce any kind of issues?
Yeah, the effects. How does the video effects work? Because yeah, you can even now some apps like make your face prettier, like something like that.
Makeup or appearance, like
Something like that.
Yeah, extra add effects on blurred, or we can call it virtual background. We do have a solution that we also offer as a service to kind of quality assure or evaluate how much of the cropping, like overcropping or undercropping, is happening, and as a result provide you with a kind of measurement.
Oh, so you can test if the blur is working correctly. Like sometimes they blur your ear,
exactly,
or sometimes they find the headphones, and there is a little space between the headphones and the head, and you can see the background through that.
Yes, exactly that. But usually we do tests without any added effects. So we're really interested in how the app is doing, how it's behaving in these changing limitations. So that's what's really that's what really matters. But yeah, of course, with virtual backgrounds, it is necessary to understand how precise it is, and that we also can do.
Does it change the device somehow? Like, I mean, is it like if I turn on the virtual background, right? So does my device does the rendering and blurring and send you the raw video, or does your device receive my video and blurs out what I selected?
or server?
Or server.
It's server. Most of the time it's server.
But there are some apps where like receiving phone.
Could be. Yeah, we don't necessarily say it's not possible. It could be the client side, but it's I would say it's bad for the developer to choose the client side, because there's less of control on the client side. There are a lot of different variations of hardware and the drivers on the hardware, so that could be an issue. And also you need to play around with what to give the processor as priority, right? Like, do we process the background now as the priority, or video, or anything else? So I think with server, you can have whatever, like, massive giant processing power to do like all crazy stuff, magical things.
But it adds extra cost for maintaining someone have to pay the bill, and it ends up on your server.
Yeah, but if you introduce this functionality, you are guaranteeing that it will work great. And if it's done on client side, you don't have that guarantee.
Nothing for free. It works fine.
Yeah.
Well, I kind of was expected it, but it does have a really big toll on either of the servers. Like, you need to add twice more servers in order to support it. blurring background. And what I noticed that if I use some of the applications which would do blur my background, my laptop is just like kind of gets hotter if I use it for like an hour or so, and it's also like draining the battery, so it's dying faster.
Yeah.
Well, I mean, it could be as because you can actually apply those background effects before you get in the call itself. So you can see the preview of your background blurred and you can see it there. But I mean, most of that now happens through like artificial intelligence and those algorithms, they are trying to be as optimized as possible so they don't use almost any resources, or the smaller the model it is and the best the predictions they have, the better it is. And now there is like a big fight of who is going to be able to recognize these edges for the face, for the things that are in front, because eventually you are only filming with one camera, and the program needs to understand what is like deeper in the space and what is forward. And
so they are inventing the perception.
Yeah, it's kind of like what it happens with computer vision and vehicles like Tesla vehicles, that they recognize the road only by the images and by representing that data into some sort of space that they can interpret, and then they can actually point out, well, this is farther away, this is closer away, just by the information of the image, which is kind of like very impressive. And they don't have in some cases like even depth, because they are just getting one single image in like camera, and they are just predicting that this is forward, this is like closer to the camera, and this is not, just by the context and everything. So that's pretty cool. And previously it was used just by the properties of the image, like just by catching the edges and then cropping it out. But that's not always the case, because you can have very contrasted areas that are not in front but are actually back in the back, and that you can only recognize it with like these artificial intelligence algorithms.
We just came back from a conference.
Yeah.
Still
Fresh in your
fresh.
mind.
But my prediction is that in 10 years time, all of our laptops will have LiDAR. Like, we have an iPhone, the depth camera, which is LiDAR, and that will definitely help with recognizing what's closer, what's further apart, and we'll see, I think we will see really super precise like virtual backgrounds, or even like you wouldn't have to you wouldn't be able to recognize if you're really on a beach. Well, maybe because your hair is not blowing without the wind, but yeah, from that perspective, it will be really realistic.
Well, I'm not sure if I will defer. Sorry. But technical director just fired me. But because I think computer vision is going to get so smart. I mean, we don't have LiDARs.
Okay, so we're taking a bet, and
Yeah, like
we'll come back to this in 10
audience,
years.
please go for it. Invest in the computer vision. So I think we as humans, we don't have that like LiDARs. I mean, we can't really say like this is that far away. And
We have 2 eyes,
we have 2 eyes, yes.
which is helping a lot.
It's happening. But we can actually have computers, phones with 2 cameras. We have already with a multiple camera system, and they can potentially be used to be able to perceive pretty much everything and depth and understand actually all the surroundings just by watching them and then looking at the stuff. For example, each day we are helping Google to make better predictions by just using CAPTCHAs, and they are just training and being able to recognize better things, like mundane things, like everything.
Are we helping Google with CAPTCHAs? That's why I'm selecting those street lamps and boats and bicycles.
So we kind of can poison the algorithm by not selecting the right items, and then
You won't ever get inside your applications.
So really, they use that?
They use that for labeling, and we are training their algorithms to be smarter.
There
So-
should be like anti captcha day where everyone in the world just clicks on different non captcha, like non valid stuff. And
and suddenly the Google Meets just start recognizing the background as a, I don't know, like a vacuum machine.
Like Google owns YouTube, right? So it's going to be on YouTube, and they're gonna be auto-generate the
Our content will be buried now.
yeah, they're gonna auto-generate the captions, and they're gonna read that like, what?
Why do we have only 2 views? I don't understand. Like just the algorithm, like the AI, the Skynet.
Okay, I didn't know that. That's new to me. But I hate those.
You're helping the machines take over.
When there was street lamps, it was easier. Now, they are tricky.
There's crossroads, right?
But yeah, what I meant with this is that I don't think we are going to be adding to regular devices like more and more sensors. I mean, iPhones, for example, they are getting rid of most of the things that like jacks, and they are trying to get rid of extra hardware. So I feel like they will try to use as much software as they can to remove as much hardware as they can.
It depends. Probably the question boils down to what is cheaper, second camera or the LiDAR sensor.
Yeah, I mean, right now is the second camera. The LiDARs are very expensive. So.
But even like with the front-facing camera, they can do pretty good.
Because they have hidden cameras there.
But it's only one camera.
No, it's only that's no. But
they're hidden cameras for face recognition. They have two and one in.
No, yeah, like the Face ID and face recognition that goes through like very different sensors because they need to have biometric reliable data. And then they have this sensor that actually projects lasers on your face, and then it reflects and gets that information in 3D.
With some other phone cameras, you can see that when the Face ID is open, it like lights up the room in invisible light. Yeah, every time you take off the phone, it's like it projects a light.
So they monitoring us like our rooms and
constantly, but in very different light.
Yeah, it's it's good that we don't see in all the spectrum of the visible, not the visible, of radio, like electromagnetic spectrum, because then it will be everything very weird.
Guys, if you have VR headset like Quest 2, you can this double tap and you can see the surroundings. So
see-through mode?
Yes, see-through mode. If you enable that and look at your iPhone, you'll see what iPhone you'll see what iPhone is doing. When Alvaro was saying that it's those lasers shining. And also like I had in the same room this Kinect. If it was enabled, you also could see.
Oh yeah, because it would track you how you move.
Yeah, and it's also using lasers to understand where you are.
Yeah, it's also like previously that it was used like the infrared to actually like the controllers and when you use a camera, you could actually see like some light, and this like in the camera you couldn't see it because it doesn't excite your nerves, but on the camera it actually does, and then you can see some flickering on that point.
But LiDAR and that laser, it's the same thing, right? Like what's happening?
LiDAR is as far as I know, they can have information for very long distances, up to 200 meters or even
LiDAR.
Yeah. And I'm not sure about the phone LiDAR because, I mean, I guess that's a simplified version of it. But the ones used for cars, they can see like even 400, 2 to some, like, and very good mapping of the surroundings. But
you can increase the signal intensity or decrease, obviously, and it will, even resolution, like at what... If actually on the iPhone you can have a 3D scanner app and you can scan any object and create a 3D model, and you can play with the resolution, play with depth.
Yeah, the thing is very, it is true that it's very precise, and it's data that doesn't have to be so much digested that is with images, like plain images, because for that you have to actually recognize objects and then predict what is the shape of it. But with LiDAR, you get that information right away, and so you can already make very good models, and then make a very good portrait mode, and then also the film. How is it, like the pro mode for filming? How is it called? Like cinematic
Camera.
And that's because they have the LiDAR, and the processing is much lighter than if you will be doing it with just 3 cameras. And so they can do this progressive like a field of focus, as it happens with actual like real cameras that have a fixed depth because of the lens. But on iPhones, they don't really have that. The lens is not working like that. So they just fake it. They have an infinite focused and a field of focused, and they just artificially include that because they know the depth of every object surrounding the environments. So
and that information is provided by LiDAR.
that information is provided by LiDAR. Yeah.
All right, let's maybe get back to the testing topic.
Testing.
So I have a question then for you. So what comes first, the software or the laboratory?
Software.
Software comes first?
Yes. So the
Okay, next one.
Period.
main argument for it is you want to test as soon as possible, and you want to start with as little as possible.
And software is
The number one that can allow you to do it, right? And that's what the developers are doing. And the lab only comes in when you need some additional. I wouldn't call them edge cases, but we can say the kind of Pareto principle thing. 80% can be tested by software only, but those 20% that from which you will have the most horrible cases will need to be tested in some kind of laboratory settings and environments.
Yeah, it's similar to the question of what is more important for like unit testing or API or UI testing. Is kind of, well, first you need to build a unit testing, and the developers can just right away do it from there. But then you need that extra attention on, well, integration and so on. And the UI testing is mostly like the last part, that, or automation, at least in automation part, is like the last part to automate. And the same is good for audio video testing. You first start with the most basic scenarios that you can write only with your computer and run within your computer, or any computer that you can deploy in the cloud, or any system that is easily deployable. And then you go to more complex cases, like building a proper lab with real devices and a more complex type of testing.
No, that's such a good of an analogy. I certainly agree with that. It's basically the level of abstractions. So yeah, it's like in regular testing, like from unit tests until you get to the very end-to-end tests. That's the same. So lab would be the end-to-end, and that software aspect or like unit testing would be there at the very beginning.
So, but I still know that you have a lab, right? So can you tell a little bit more? How did you create the lab? What maybe were the issues? I know that the cables were a big thing, that not the regular cables from your grocery store is not the best ones, right?
Yeah, the lab is its own thing, because to have reliable data and something that you can reproduce to other setups and to other phones, like imagine if you are testing with one phone and another phone, and you want to replicate the same scenario in a different like place or with different devices, you need to make sure that the boundaries, the environment is as close as it was with the other one. Otherwise, you test audio quality, you test video quality, you say that the scores are lower, and you're like, well, yes, but it's because the wire was faulty, it's because the position of the phones and recordings were different, and the situation is like just in generally different. And as we mentioned at the beginning, there are so many variables that affect that we really need to keep those
under control.
very, very much under control. And well, the setup, and it includes also the wires. What you said, like this is a funny story, and we had it for some time that we were like having these setups, and one of them was working fine. We thought like we connected everything exactly the same, but the other one had like terrible audio, terrible noise, and we were like, what is happening here? And we eventually got to see that some of the USB-Cs to USB-C wires, even the originals from the phones, were having a lot of noise coming from the electric connection and earth connections. And then you connect a different cable that it was even like a third party, like from, like these bazaars, and it was working better. And it was like, what is happening here? Like, why is not the earth isolated or like noise isolated? And yeah, that happened pretty often. And even I bet some of the audience people have experienced sometimes. You're calling, and then you plug the charger, and suddenly, sound like coming in, like some rattling sound. Some of them are worse than others, and this is pretty much because either the brick doesn't have good like isolation from like the network, the actual like outlets. And sometimes it's just like it's faulty for some reason and it's just adding noise, but they don't really care about adding noise because, I mean, they are not audio video testers, the ones that develop these bricks, so they don't care. But that's actually a problem because in these setups, we need to constantly charge the phones. Otherwise, the batteries are what they are.
Oh, so that makes the lab more complicated because you have to share the same slot. So you have to finish the testing, unplug the audio cable, and plug them to the wall.
Yeah, we have a system that we have always charging, and so we have the phones plugged with the audio jacks, and then they are also plugged to a power source. But we have to use a special like power fed for the devices, because if you plug them directly to a regular outlet, there is a lot of noise going to the device, and we can't have that. So we plug them to a hub, which has you've seen sometimes in these cables that has like a wrapper that is like plastic
braided cables.
Could be that name. And that is actually it's a capacitor which remove
not the braided.
Oh, those
it's
like magnet something, right?
It's you have this wire, and on the wire you have this cylindrical form object.
Yeah.
The more expensive wires.
Yeah, like a lot of
most of the laptops, older laptops.
Yeah, older laptops have them, and that reduce noise. Like from electrical engineers, if you're listening, they will understand like how like RCL.
And we're sorry if we're not describing it correctly. All the words.
But that's kind of like filters for high frequencies and
so you had to find the wires with that, or did you make them?
We found it. Like we found some hubs that have that already on them, and then you plug them, and it's like they don't introduce noise to the device, and that's great. But the other thing is there are some computers for some brands that they have very bad ground isolation, like they just fit, and it's kind of like you have experienced sometimes that you touch the computer and it gives you like a
I have.
Max, especially electrostatic discharge is so often.
I got used to that so much that it's like I need that jolt. It started like it's like a
instead
a
of coffee.
Yeah, it's like a habit now. So I need to.
Good morning, sunshine. Yeah,
it's so weird.
Yeah, it's weird.
I used to like there was a specific metal piece in my home that I would grab it and then because
you ground
if you
yourself.
have it, it's all right.
Nice.
And if you forget,
Yeah.
So you have all these carpets, especially like the one that we're sitting on right now. It's you charge on it, so you and then you discharge there.
Yeah, and if you wear like a full body pajamas and then you start like rubbing your feet,
Oh my
then
god.
you will
Yeah.
you're Electroman.
Yeah.
So
Sometimes when you like taking it off.
Yeah.
At
Yeah.
night,
Jumpers.
even if at night, like you can see
You
like
can see the lightnings,
Yeah.
little
Yeah,
lightnings coming off.
So that's something that we have to account for when we are doing this, and this is mostly for the audio part. Like the video part doesn't have so much problems on that regard. There are other issues that we have. Well, yeah, but not at least in the noise, like electric connections, we don't have that kind of problem. That's mostly for the audio part, and it's very very annoying because we have to control that very very tightly. Sometimes devices start to behave over time because we do extensive testing over some devices, and so we have to check them every now and then.
so basically unintentionally you do like
Endurance?
endurance testing. Yeah. So unintentionally you do an endurance testing for a device.
It is because one of the problems is the heat. So you also need to think of heat dissipation. So it really literally works all the time, 24/7.
And they were not created like they were created like you have a 15 minutes call at most, and then it has time to cool off.
Yeah, and you have the constant video calls and audio calls and streaming services running. So it's so hot. You need to think of fans, especially in automation setups.
And that's additional audio, right? Nice.
And that's additional, but there's the thing. So you have to think, especially in audio setups, of different. The best way is digital audio, so you don't have any signal interruptions or anything like that. But what I wanted to mention about this heat. So in winter it's fine. You get like additional. You don't need the heaters. But in summer it can get really bad. So yeah, we kind of always, if there's a new automation setup, especially with different combinations of devices, that's already something we need to solve before we go to the actual setup.
So how often do you need to change the phones? How like let's I assume that the phone lasts for at least 2 years, like, right? That's the warranty period. So if I buy a new phone, for me it should last at least 2 years, like probably more. But so how long does the device survive in your lab, just without naming the devices and such?
Yeah, it depends on which devices. Some devices are more prone to be funny, and some
Funny to be funny. That's how we call it from now. So
They start to behave.
so what is the funniest device?
the ones that duplicate size, you know. They grow. They are
I
like
understand
your own child. Like, oh my god, you still.
Yeah,
But-
that's again that heat
They
problem.
The folding one.
Oh,
no, like they just grow in like thickness because the battery
Battery expansion.
That's
So
the
Samsung.
most common.
that's the most common thing. that
Really?
Like Samsung Notes, the ones like, no?
It can be almost any device, and
Yeah.
imagine it's also iPhones.
If we continue with that problem of heating, and this brings to another kind of testing for actually these audio video applications, which goes to the performance and battery testing and how the GPU and CPU behaves when they are running this.
Thermal throttling, right?
Yes, because there are some applications that they handle very bad the rendering, or they are using so much resources of the phones that they get very hot. And it's not nice to be in a call with 8 people in like rendering 8 videos, and your phone is starting to be fire, and you can even cook eggs on it. So it's not pleasant. It's not a user experience, you know. Even if you have like, oh my god, my application has like crystal clear picture quality, very high frames per second, but is actually the temperature of the sun. So it's like your phone just put the sign, your phone is too hot to be used, and it just turns.
Yeah, that
Flies away.
happens in the summer a lot.
Yeah. and that's not good, and mostly because there are some phones that when they reach certain temperature they just go out even sooner than others. Like Android, some Androids, they let you go to very high temperatures and they still run. It's not good. It is not
But
good.
they still work.
But they still work. They allow you to work. While iPhones, for example, they will dim your screen, which I personally find it very annoying, because if you want to force it to have high brightness, you can't possibly do it. And I'm from Spain, and there are many days which is pretty hot, and I'm at the beach and sunny, and I'm outside and I'm looking at the screen and I say like, well, either they're dead or they just dim the screen, because I don't see anything whatsoever.
And you cannot check because you press the button and it's just dark.
Yeah. So the only thing you can do is like try to guess where are things, and and try to guess that you are not calling your grandma or something like that in the meantime. But that's why it's very important to optimize your application, like the audio video applications, because sometimes you have like these 8 user calls, 8 video streams coming to your device, and they are sending maybe like full HD for each of the streams, and it's like, why are you sending that if you are presenting the video in in such a little screen? You're just using
50 on 50 like pixels or something like that.
So it doesn't make sense to send so much information, to make the phone render so much information, and
making it hot, making the battery drain faster.
So this is all the results that you find while doing the testing, right?
Yeah, that's like some of it. Like there are, as we've been mentioned, like there are a lot of variables, but there are also a lot of outcomes. And there are a lot of things that we've discovered over time, and we grow like on our knowledge. That's why like we have this advantage, like competitive advantage against any other like company that does testing for audio video, and is that we have a wide experience on this kind of applications. And there is plenty of more things, and some of them we can talk, but some of them we can't, because, well, IP and stuff. But I mean,
one really practical example of transitioning from a desktop device to a mobile device, what is the usual caveat for any developer, and Alvaro already mentioned it, is the amount of data they send and receive is so high. It makes CPU really, utilized on a very high rate, and as a result, you get lower frames per second. So lower fluidity. They still try to keep high quality images or frames, and then they most of them don't understand why their users are getting really pissed and leaving bad reviews for mobile apps, right? Because like functionality is great, it's usable, it has really great UX, but once you get into the call, especially with the desktop device, so there are different combinations.
So that's right. So you can also have a video call between the phone and a desktop device, and different kinds of desktop devices, different kinds of phones. So that's so complicated. You have to multiply everything by again, and tablets. So phones, tablet, desktop devices, right?
Yes. So yeah, and you get really these reactions from reactions on the other reactions. Like it's so much interrelated that you look like, there's enough bandwidth, but why I'm having this bad frame rate? Or even some of the apps will try to tackle it and decrease the quality. So you get this high bandwidth situation, bad frame rate, bad quality, but then you look at CPU, oh, okay. 100% CPU, the phone is hot, battery is draining so quickly. And that is one of the conclusions you get to the client. Okay, you have to use less bandwidth, and that's it. Try that one, and in most cases that solves already like 50% of the problems, and then after that you get to tune it.
But they do collect the data, right, to make those not decisions, but make those like insights.
Yeah, for sure.
We collect CPU, GPU usage, RAM usage, and so forth. So it's that's why like the data analysis takes so much time, and processing is quite a big part of all like the pipelines that we do in audio video testing. And well, coming back to the laboratory itself, because we have covered the wiring, the heating. Then for mobile to mobile testing, we can't. There is no possibility to actually feed the video directly to the like sender phone. Well, because we have one sender, one receiver, and we do measurements over the receiver. So one phone, we do the yes.
Yeah, because I'm pointing to you because like when you say directly feed, what Alvaro means is that on the desktop to desktop test, we can mimic the camera.
We can do virtual camera.
Yeah, we do virtual camera, and one of the software we use is OBS. That's also used for streamers, and with that, you can feed any video, and that's the best.
Yeah, on the phones is a whole new thing, and so for the phones we have to actually use the cameras of the devices and film some content. And the problem is that we can't just film like random content because we want to make repeatable tests and being able to control, as we said, like have the all the environment as tight and enclosed as possible. So what we use is like high refresh monitors, very good quality monitors that we have a playback that we control of video, and we film that through the phone camera, main camera. And well, this means that we for mobile testing we can't really use like the algorithms that are used for video quality, the full reference algorithms, which what means full reference is that you compare the source media file with the degraded media file that comes after that video is sent through the phone to the receiver side. And the reason is because when you film with a camera, external monitor, and even if it's like a video that you have, you own the media file and you know how it is. When you record it with the camera, you add geometrical distortions, like the edges have a bigger distance to the center, and so it's kind of like expanded toward the edges. It's not too much, but it's enough to not being able to do like a full reference comparison of pixel to pixel. That's one of the things. The other thing is that the color accuracy is not perfect. So the histograms are a little bit different. You can, again, like you can do like apples to apples comparison in that regard. And then there are plenty of like optics distortions, not just the geometrical ones, but there are aberrations and like plenty of things that will modify the media source content to the actual filmed one. And that's why we use, in this case, artificial intelligence to do video quality predictions of scores to understand how the video quality is presented to the end user without using any reference. It's kind of like, I see a video and I say like, this looks good. And I see a video that has very poor quality and the algorithm said, this is bad quality. But it only sees that single video without any reference.
Really? How do you achieve that? How did you taught your machine learning algorithm?
Welcome to AI. And computer vision.
And all that to just test
It's
video.
a setup.
Like, I am not valuing my video calls and YouTube streams as I should be. They're working way better. Someone put a lot of job to...
Yeah, I will go to that after I end up with this laboratory setup. So because I mean that's its own topic. It can take quite a long time. So I want to kind of like finish with this laboratory thing, and when we do this like filming of monitors and then receiving, we have to keep all the variables very close. So the orientation of the phone has to be the same for all the setups. If we change it, or if we change like a light of the monitors, if we change the like the tilt of it, it has to be fixed, and the distance to the monitor, it has to be fixed, because if you change it, then you will have kind of like, it's not so different, but it could be enough different to make maybe a 0.1 score higher or lower. And if you do that in a trend line, or if you want to repeat your setup in a different location and you have like a different score, then it will raise concerns to the client. And so we need to keep those like positions and variables as well in a like a table, like table sheet with well, these are all the orientations and
so
such.
you come in, you want to run the test, you take the table sheet, right, and this phone like this, the monitor a little bit up, camera a little bit down.
Well, we the labs that we have designed them in a way that they are built as like IKEA boxes, that they have these requirements, and then we have the materials, we build them, and then it's repeatable. It's not like we are just placing things there and that's it. So they are repeatable. We can place everything. We have holders for the different models that we have been printing with 3D printers, and everything is well measured and well put. So we can have that measured.
So when you're designing the mobile app, it's not only that you need to devices, wires, the configuration, right? You also have to make it set up in a way that it can be repeated. And you said boxes, so that means that you have more than one.
Yeah.
And interestingly, the very first lab setup was in a room, and well, that's not so interesting.
We had walls and ceilings.
The interesting part about it is that it was a totally pitch black dark room. So really, well, we didn't use that, the black. What's it called?
Comta black or
Yeah.
Ultra black.
Yeah. That black. We didn't use it, but actually, like, I think we should use it for the boxes.
yeah.
Because we have a kind of a drape. So why it's needed? It's the opposite setup of the video podcast setup, right? It's totally opposite, because we cannot film the monitor with additional lights or just any variable lighting conditions.
It's enough to screw the comparison.
Yes, you will get different artifacts on the recording, and that will mess up the predictions. Like Alvaro already said, we'll have different variations that can affect scores from 0.1 to even like 0.4, 0.5, and that's a huge difference.
What is the scale from 0 to 1?
From 0 to 5.
1 to 5, because
1 to 5, yes.
1 to 5, so
10%. Yeah, up to.
So yeah, and that's a big difference. And the usual human perception score difference we give like 0.2 or 0.3. Well,
so that a human can perceive.
Yeah, that change will kind of, I noticed. And yeah, we started with the room, and we quickly, how quickly, I think maybe within a year, understood that it to actually scale up, we need to scale it down and make more of it.
Oh, so instead of, like, you needed bigger space, right? So instead of getting the second room, you moved to the boxes. That's outside of the box thinking, right?
Yeah. When Deniss was talking about thinking outside the box, I was actually thinking like, well, we literally thought outside the box in most situations. So yeah, it was figurative and literal sense.
And also funny is that they're all black boxes. We're doing black box testing.
Black box testing.
Yeah.
Nice.
Yeah, we also try to constantly improve on its mobility of this box.
How big is the box? Like, is it bigger than two tables? One table?
The length of these two tables, and it's about this.
So like a one table.
Yeah, we'll actually say that it's one table, but from the legs like this kind of like this is the length, and the width is kind of like this. Yeah.
And the height?
Yeah. Well,
From the table or from the ground?
Is it like it has the table has legs, because you have to put it somewhere. But then I will say like is the height of a monitor that is in portrait mode.
Yeah. And the count, we have them around 50 plus.
Could be. I mean, we have boxes in Spain now, so
yeah, it's more. The number is growing.
It's growing, yeah.
And the monitors, do you have to calibrate them?
Yeah.
Yep.
We have
Specifically.
calibration devices that, as Alvaro said, we need them to be exactly just like the positions, the calibrations of the monitors, the devices.
The color science behind, we use the same. We also use the same brands, like the same model for all the setups. So it's.
Was there some faulty models?
No, the problem is that we at some point we were using some like lower frequency monitors, and then we were seeing some artifacts because of their recording, and the camera was like unmatched, and then you have like some artifacts arising from that fact. Yeah, I mean, we've seen maybe sometime like back that monitors that didn't have enough brightness, or that weren't like a little bit different than others, but it's at least we try to keep everything as constant as possible.
That's so interesting. Like, if you want to test something and it's precise as this, every item you are using is tested like indirectly. Like this one, like I have 5 monitors, like this one is not bright enough, this one color gamut is off, this one okay-ish, that one okay-ish, that one okay-ish. That's like what, 60% of the product is correct?
Yeah, when you are testing hardware, you have to test the environment as well. The testing devices, you have to test them, and you have to calibrate them. So that's a very interesting thing, because without calibrating the sensors or the things that you are using for the testing procedure, you have to test all the things, and that's something when you are working only with software. You are only worried that maybe you Dockerize the environment and that's it. You can deploy it whatever you want. And
so, like, you need to set up a test environment, right? And I thought that's hard, but boy.
There is so many variables. It's crazy. It just piles up.
But you also have to make sure that software on each device is the same, right? And you have the application version.
Yep. So
we need to keep that in mind too.
We report in every test that we do. We report the software that it has, the hardware, like the version of it, and we also report the application version. And we disable the regular automatic updates for them, because if we are testing with automation and we are testing over time, if things change. There are some clients that they want to like do the auto update because we want to see live things going on, but for others we disable it and we keep like this, and they tell us, well, it's time to update and see if we have improved in any way, and then we update the devices, either software or the operating system or the application version, and then things sometimes goes better. Sometimes it goes terribly wrong, and that's there has been like times, this is an automation nightmare, that I've seen applications that they, without software updates, which is like the interesting part, they can deploy features over there for a specific users, and suddenly the application starts behaving better, then bad, then better, then bad, then better, and it's kind of like every week something new happens, and it's like, oh my god. And sometimes even like UI changes, that they rearrange the way that they are displaying the media.
Also for specific users.
Yeah, for specific users.
Oh, so they're doing A/B testing invisibly.
Yeah,
Can release.
deploys in production.
Kind of.
Yeah.
Good job. and it's
And it's messing up the automation. Like, that device
yeah.
worked, this one doesn't work. Why doesn't it work?
yeah, like
And you need time to investigate, and you investigate, and then it turns out, oh yeah, this user was under some sort of experiment. Like, oh my god.
yeah,
I didn't know that.
yeah, and
Like, they're experimenting on us. Like Google collecting my CAPTCHA for some information. Now applications, damn.
And then you have very dedicated ads without even doing any searches.
Somehow I'm already like made my peace with that. But now, like, interesting, you know, I'm just thinking, if they are doing this features for some users, right? So do they choose the users? Which means that they collect some information to choose you. Like, are you early adopter or late adopter and something? Or do they do it on random?
Yeah, I'm not fully sure, because sometimes we've seen it randomly even for us. Like, I mean, we have the clients, and we have them randomly deploy things, and it's like, why have you done that? And without not like telling us anything. And so it kind of feels like it's a bit randomized. But it is still very annoying for the automation, because sometimes if any of you have done UI automation and you get like elements changing and the ID is changing, then the automation will start failing, and then you change the script to start working again, and they roll back. And yeah, like I'm telling you, like there was one month that they were putting it, rolling it back, putting it, rolling it back, and it was like, just choose one. Just
why are you messing with me?
Yeah. It was really, but then there are others that are not so problematic from the automation standpoint, which is just they change the codecs, and then suddenly, well, instead of 30 frames per second, it drops to 20 or to 15. And it's kind of like, oh well, your application is now behaving worse. And they are just doing some experiment. They have that report live. Which means like after the post processing has done, we update data to this kind of portal,
and it's doing it constantly.
Yeah, and so they can see that it has dropped down. But yeah, we see those behaviors quite often, and when we see one difference like that something has changed, either for good or for bad, we make some sort of investigation. We collect the traces, we collect all the data that we have, we watch the videos just in case like there has happened something on the setup itself, and then.
So you film the setup?
We have the media, we have the audio data, and we have the video data. So we like manually inspect it just in case like something has happened on the setup itself, because you can actually kind of get that information out of all the data that we have. So then we do all the investigation, and this is not. I mean, one of the reasons is to check that all the setup environment variables are right, but the other one is to give a comprehensive report to the client and to tell them, well, yeah, this happened because suddenly the bandwidth that you are using, instead of being 2 megabits, it's like 200 kilobits, and it has reduced by 1/10 of the data, and without any network limitation applied. So it's kind of you have done something in your code, now it's thinking that you have less data available, and then it's going bad. So your bandwidth estimator is not working correctly. And so we kind of have give this kind of comprehensive reports to them, and for the developers to understand also like where to look at.
It's
And
like root cause analysis, right?
yeah.
for every incident.
Yeah. Even though we don't have access to the code.
And not only incidents. I just wanted to add that audio and video testing is one of those areas where you do have to do testing of the testing kind of thing, because for us we call it validation of the results. So the process is we capture the data, then we do processing, and then we do validation of those results to understand if the results are valid. And that's so important, because like if we do see some anomalies, well, not even anomalies, but let's say it's a negative result, we need to make sure that it's not false negative. If you have a setup, automation setup running autonomously, and someone comes in the room and just, oh, what's there?
Yeah.
It's good that we didn't do that. Right?
I tried.
Oops.
And then there's this test result. Whoa, something happened.
And the client says just a face of one random person. Hello.
All right.
Yeah.
So it's really brittle, right? It's easy to break them.
Yes
well,
and no.
Yes and no, yeah.
Physically, yes.
It's flaky. It's flaky.
It is easy to break. It is easy to break them if you don't have the control that we have. If you don't know all the things that can go wrong, because for someone that goes like right into like audio video testing, okay, just put the phone here, monitor, whatever.
We build fail safes, a lot of them.
Yeah.
Yeah, that validation and so on.
Yeah.
So it's fail safe in the process.
Yeah.
Okay, so that's the current state of the industry, and like CV actually pushed it to, I guess, to new heights. But what's in the future? Do we have like VR, more of the like Metaverse things, AR?
Go for it, Dennis.
Yeah. Actually, one of the things that we tried in the latest conference in Amsterdam, the AI conference we were at, was the HoloLens 2 from Microsoft. And that thing is just something like whole new stuff, like from the VR, in my opinion, because you're connected to reality. And
so it's AR, augmented
yes,
reality.
augmented.
well, or you can call it MR, mixed reality as well. And there you can have any 3D objects, obviously, at any, again, in any levels of depth. And obviously you can have calls and other interactions. So the way you do interactions is that you can connect to other person also like online, or you can be in the same room and you can see him from
Like in the movies, like I can see the hologram, right?
Yeah.
Like in the Westworld, I put on the glasses and I see.
Right now, it's not that advanced yet, but they're getting there. And they have produced already kind of real life holograms of humans, but it's not yet as you can chat and interact fully. But I think that's where we could be going. Obviously, there are different options and ways this can go. There are different groups of people who like it and not like it, but I think this Star Wars thing, kind of hologram, where you just have they had this pod underneath and then the hologram was there, but here you don't need those pods. You have just an eyepiece, and in future I think it will be just it could be embedded in your skull even, or wherever, and you can see it as your normal vision.
Neuralink
That's
kind
the
of thing.
future I don't want to be.
Yeah.
Well,
So if you don't want to be there, you can have some kind of like lenses or glasses. So I think like having glasses is okay, especially if you need additional information on top of the real world. There are so many beneficial applications that don't ruin your real life experience, and I think that's very important. But for this particular video and audio testing case, we are already looking more in depth, and Alvaro will be leading this. So we were looking into AR with online meetings and online interactions.
Because I mean, eventually the technology and all the devices that we use, what we are trying to accomplish is that the interface between us and the virtual world becomes like faster and faster, so that the interactions that we do are instantaneous and not just like slow.
And now it's limited to our
it's limited to our and also like the way we perceive it is also like attached to these like screens, and having augmented reality or virtual reality, it kind of allows you to be more immersed and to understand that world in a different way and to access the information like sometimes better, sometimes better in different ways. That is faster, better that is that you can handle it in a more like visual, or moving your hands, or like for any product that comes, you first build this proof of concept that is not much usable by the user, but it implements new features, and then you shrink it to a format that any user can use it. And it is true that right now you have these lenses that are a little bit bulky, but they are getting smaller and smaller. And actually, like right now, Meta partnered with Ray-Ban, and they are trying to do these kind of like devices that they are like glasses that are good looking Ray-Ban glasses with cameras, and you have I'm not sure if you have like actually like a virtual environment, but they have these cameras and you can do some stuff. And in the future, I feel is like you need a product that is appealing for the public, that is not too intrusive, so that you can just put it and be a regular person, and not just a freak with like a helmet like the size of
computer on
like,
the back.
It's like in the 80s or 90s, they it was this joke about
the hacker man.
it was this joke about like one person traveling and having a phone and with a suitcase, and it was like, oh, you're throwing away. I said, no, this is the batteries of the phone. And and so you need something that you can actually carry it and do it in a functional way, and that it is also stylish. I mean, iPhones are pretty much like a symbol of style right now, it is like good hard piece of hardware, but as also they are looking a lot for all the phones to have a good style, and that you can actually ergonomic and all those kind of things. So
and then you put it into a case and poof.
I hate cases. I have a case, but I hate cases.
Cases are good.
So then Mark Zuckerberg is kind of correct, but maybe just ahead of its time. All in for Metaverse.
So it is. I mean, sometimes you try to push some kind of technology, and then the usage is like going to like sideways. Like you develop something that you think, oh, this is meant to be used like that, and then the end user uses it like a very different way, and it's like, oh, I didn't see that coming. It's like the internet, and like it wasn't really designed to be this platform of sharing information at the beginning, but like in 2001, that film, the Odyssey, Space Odyssey, like there were. They were thinking in the 60s that the technology that will arrive is that we will have space stations in the moon and Mars, and by the 2000, like it will be like everything will be in like interplanetary. But then the thing that they laugh about is that there was a computer that you asked for something like what is the weather in this, and it answered you with an actual answer, like saying, well, the weather is that, and this planet has no whatever environment, and they were laughing about that, like how can a computer answer you with like processing, like natural language processing, which is now a thing. Like we have Siri, we have like the Google Assistant, we have Alexa, and it's getting better and better. So it's kind of like you design the glasses or you design this virtual reality, and then the user start using it for I don't know exactly what, but it's kind of like very exciting to see what the end user ends up to like.
I want to give you a really quick use case, what might be of a thing when we'll have these online conversations. So now, to collaborate on something, you're in a call, and then you're working on a, I don't know, Google Sheet or Google document together, kind of commenting on things. If it's a design, again, you can like in different design apps draw something together, maybe model on 3D objects and things like that. But with this Magic Leap or HoloLens or this Quest Pro that is being developed, and other these AR mixed reality solutions, I think the use case could be like you have developed your own just 3D object, and you can send it over to the person and work together live on it, and you can
So
change.
like on those like in sci-fi movies, right? There is like a cube and you like Tony Stark, right? From Iron
It
Man.
actually worked like that. We were testing it, and
Really?
yeah.
Yeah.
And nothing in your hands. Like
You can touch the holograms and change them and do anything
was
with your
impressive.
bare hands.
But wasn't this like awkward? Like, oh, it doesn't have its like physical properties.
Yeah,
Oh.
but that's the thing about the brain. You start to get used to,
And you start to actually kind of feel that there is something. Obviously,
Yeah,
there
it's
is nothing.
mocking.
Yeah,
The
sensation
future
of
is
touching,
here.
Yeah.
brain is a very malleable thing, and it adapts to things very quickly if you feed it with that kind of information. And it was really strange but also wonderful to actually interact with those objects, paint like a 3D box, and then put it bigger, smaller, rotate it just with your hands. It was like
That's
weird.
awesome.
It's awesome, yeah, and you could potentially have like this kind of virtual meeting, have like a screen where you can see this other person, and this other person will be also modifying that box, and or maybe designing a piece of like I don't know electric motor for some other company, and say like no, you have to like put this here, and then you point in the 3D model, you rotate it, you do those interactions, and it's pretty amazing because that. And this is what I meant with interfacing with the technology. You can do it more efficiently, more like with more information about the objects, about that virtual environment. You can interact with it in a wider sense, but that also brings problems of how to test it, because the testing part is a challenge there. Like
A lot of manual labor.
yeah, at first it seems like it will go through manual testing because understand, like for an automation framework, to understand the environment and to actually modify them and or make tools to be able to simulate the actual like physical interactions of your hands. Because when you're talking about virtual or augmented reality, it's not just the keyboard, the screen that you are interacting with, but it's your whole body.
So now it's going to be the real world. So we have to have a human-sized robot.
Yeah.
That's the way to go.
In a way that video games, it's the same thing. It's like you can't automate it that well, so it might be like we might reuse good practices from video games, how to actually test the virtual.
Yeah, I mean, in the future, it could be that it's like some sort of AI that actually tests itself. You know, it's kind of
robot.
and a real robot and tied
like
also.
Tesla have a robot coming up soon.
True.
So
It's,
there are like, okay, so you can have artificial intelligence, real robots, and maybe there is a third way that you make a digital twin of it and test it as a software in virtual world.
Yeah, but that will be more like unit testing it, because you lose all the end
Physical
properties of it. Like, what if the sensor are catching, or the drivers with the sensors are not working properly? And
you can emulate, but again, that emulation part is the one that kind of is the not shady part, but the unknown part. Again,
What if the bus of communication between the sensors is not fast enough to catch the movements of, because you can emulate those things, like you emulate the information going in, but what if the lag is on the sensor part? And so like it's kind of like, yes, when you are emulating, you are modifying the objects in that virtual reality like that, and it's working fine. But once you put a person, you do this, you expand it, and it takes like 2 seconds to actually expand it. And then you're like with Windows,
Blue screen of death.
yeah, no, or with computers when you're opening like a program and it's like, oh, it's not opening, and you start clicking, and suddenly like 2,000 windows appear, and it's like, oh my.
or blue screen.
Or blue screen. Oh, the blue screen of the 2,000 windows. That was a great experience. I'm old enough to remember that. I just right there, but I still remember that.
Like 11 and 10 also had blue screen of death. It's not a new. It's not.
Yeah, no, but I like the Windows 2000.
Yeah.
Like
It was before or after XP? Before. After.
before the XP, because before it was the 98. If I remember, then was 2000, and then rapidly
NT was it?
Yeah,
NT
2000s they like Windows Vista of those times.
Oh my God.
It was sudden and died.
yeah. It was interesting.
But it's quite interesting because that would allow more remote workers to be more connected, I guess, and maybe rest of them who wants to be in office could be also going to like working remotely, because it will give you more possibilities to cooperate, to work together, and just you just connect the VR and then stay a whole day like near a laptop working, and then people can see you. Like sitting near a table, virtual table, like working, like
we can have a podcast. Podcast really not well.
That's not something I'm waiting for.
He's a skeptical one, so yeah.
No, I'm just enjoying. Like I like work from home, but I enjoy some kind of anonymity, right?
Yeah. But it is true that with this like virtual reality, and you could actually have like drones that you can control remotely and do labor on places that are not so pleasant to be. I mean, it could be like fabrics for cars, that they are like heavy machinery, and you don't want people to be there, but you can have like a person controlling a drone. You don't really have to build a robot that does everything a human can do, but you can have a human that controls a robot, and you can do it with this virtual headset and actually like move your hands, and then the robot will do whatever you think. Because
so you could do operations, and I think now it's even possible. Some I think in USA they control those excavators.
Oh yeah.
So there are people who go to the shipping containers, sit down and control an excavator somewhere.
Yeah,
you
true.
also have the remote hands, like what Bezos showcased. So you kind of,
The time might be like, I'm not even sure. Like it's 23 minutes, so
let's record the ending.
Yeah,
sure.
Just in case.
Just in case.
So it seems that the future of video and audio testing is quite bright. There's a lot of things happening, and more interest, and like technologies are going to that direction. And it seems like a lot of things might happen there and soon, especially AR and VR and MR as well. So I guess that could be end for our current session. If you have any questions or you have any comments, and if you want for us to like invite Alvaro and Deniss again, then please give us a questions, and we can like have this discussion further. Maybe AI, maybe digital twins, maybe something like quantum physics and so on.
Oh yes,
I don't know. It's also another topic we can discuss. So, yeah. So thank you for watching this episode. Thank you for the guests, for sharing your time with us, explaining stuff, and like all this information was quite useful and interesting. So, thank you.
Thank you for having us.
Yeah, thank you guys.
Thank you. And bye bye.